Welcome to the online video. So in this session, we are going to learn about routing. So basically, the routing is the important responsibility of network layer in computer networks. So the third layer is network layer. So the networking layer, important functionality or responsibility of the networking layer is routing. So first we have to learn the definition of routing. So it is the process of determining systematically how to forward the messages or the data packets toward the destination node based on the node's internet protocol address. So this is the definition of routing. So basically we are having two different methods for routing or two different approaches for routing. One is the routing information protocol RIP, and another method is called as Open Shortest Path First Protocol, OSPF protocol. There are two protocols for performing the intra-domain routing. So basically, RIP and OSPF comes under the intra-domain routing. Within a domain, the packets can be transferred and it can be shared. So, so in this session, we are going to learn about the Routing Information Protocol, RIP. So the routing information protocol, uh, it uses one algorithm, and it is a very simple algorithm. So the name of the algorithm is distance vector routing algorithm. Distance vector routing algorithm. So basically, so first we have to know what is the key aspects of the distance vector routing. So the three basic aspects of distance vector routing is each router will have the knowledge about the entire network, whole network. So this is the first aspect. Every router in a network has knowledge about the other routers in the network. Each router has the knowledge about the whole network. The second key aspect is it sends its routing table, it shares its routing table only to its neighbors or the neighboring routers. So this is the second key aspect. And the third key aspect is the routing information is shared at regular intervals. So uh, during the regular time periods, the routing table is shared by all the routers. So each router has the knowledge about the entire network. So that information is shared to only its neighbors at regular intervals. So what is the algorithm which is used? Distance vector routing algorithm. Distance vector routing algorithm. So this algorithm has been so the base of this DVR approach is a Bellman-Ford algorithm, which is also called as the all-pair shortest path algorithm. So this basically works based on the hop count method. So let us consider a sample uh, problem. So first we have to take a graph. I'm just going to consider a graph. We'll consider a sample network. So the distance vector algorithm. So this is the graph I'm going to consider. So this is a graph which I'm going to consider. So this is having nodes from node A to node G. So as we all can know that this network, so this network graph basically it is an unweighted graph. So DVR algorithm we can apply DVR algorithm and so distance vector routing. Distance vector routing. So this is we are going to learn. So it works based on the so we can use DVR only when the network graph is unweighted. Un Unweighted graph, and also when the graph is undirected, undirected graph. So first, so unweighted and undirected. The graph must be unweighted, undirected. Then the approach it is going to use is the hop count approach. Hop count approach. So these are all the things we have to ensure before applying the DVR algorithm. So so there is no edge weight uh, is present between the nodes. Uh, so it is unweighted graph. As you can see, there is no edge weight is given. So it is an unweighted graph, and even the links, it is not the link between A and B. They have not provided any direction. So it is undirected graph. So unweighted graph, the graph must be unweighted. The graph is undirected graph. And the approach we are going to use is the hop count approach. We are going to use the hop count approach. So for solving this problem, for finding the shortest path, so what we are going to see is so this DVR algorithm is also called as the so the base algorithm for distance vector routing is Bellman-Ford algorithm. Bellman Bellman-Ford algorithm. So this Bellman-Ford algorithm, it finds the distance between all pairs in a graph. So it is also known as all pair shortest path algorithm. It is also called as all pair shortest path algorithm. So first we have to construct the routing table for a specific node. So first I'm going to take the node A. For this node A, I'm going to construct the initial routing table. For node A, I have to consider the initial routing table. So how to construct? I have to find the distances for reaching node A, for reaching other nodes from the source node A. So first I'm going to consider the initial node as, I'm just going to consider the initial node as node A. So this is the, okay, we can do it here. So this is the graph we have to, this is the graph we have considered. So initially we need to find the cost of reaching, from node A to other nodes. So in the routing table has three different fields. The first field is the destination. So in destination we have to write the node except the remaining nodes, except for the source node. We should not consider the source node. Why? Because from the node, if you determine the cost for reaching the same node, the value will be 0. So we need not write A here. So we are going to find the cost for reaching B, C, D, E, F, and G. So we are going to find the cost for reaching the remaining nodes. So this is the, I'm just going to construct the initial routing table for node A. So what is the path? So first here we have to identify whether there is a direct link is present between the node A and the remaining nodes. What are the nodes having the direct link? So here the cost to reach node B is 1. Hop count is 1. The hop count is 1. The next stop router is, so in order to reach destination B, I have to jump to B. Similarly, there is a direct, you can see there is a direct link is present between A and C. So the hop count is 1. The hop count is 1. The cost is 1. The next router is C. So for D, in the case of D, there is no direct link between A and D. So uh, I cannot determine the cost in the first run itself. So what it will assign us, it will assign a it will assign infinity value. Since we don't know what is the cost, so I can insert the symbol infinity here. So since there is no direct link, I have to determine the cost for reaching the node D. So hence the cost is infinity. Even I don't know what is the next stop router. So next stop router is dash. Okay. And for E, for the next router E, since there is a direct link between A and E, the cost is 1 and the next stop router is E. In this case, the next stop router is E. And for F, since there is a link is present between A and F, the cost of reaching is 1 hop count and the next stop router is F. And here in the case of G, there is no direct link between A and G. So what we have to substitute? We have to substitute fill as infinity. So we need to determine the cost. So at first I'm giving a value as infinity and I don't know what is the next stop router. So it is dash. So this is the initial routing table. So similarly, what I have to do is I have to okay. So now this is the first step. So each router will construct this kind of a routing table, all the routers. Even uh, at node B also, a initial routing table will be constructed. So for example, in the case of node B, what it will do is, so it will, for what all the nodes, it is having a direct link. For A and C, it will, the cost will be 1 and the next stop router for A is A and the next stop router for C is C. For remaining all other nodes, in the case D, E, F and G, it will mark as infinity and it will put a dash. So this is the routing table of these. So we have learned the three basic key aspects of the routing, the distance vector routing. So each router has knowledge about the entire network. So each router has the knowledge about the entire network. Means what is the cost of reaching to remaining nodes in the network. Okay, so it will have the entire network. It will share only its neighbors. It will share the routing table only its neighbors. So now what it will A will do. So A will share its routing table with B neighboring routers, with C, and with E and with F. Okay, so the neighbors of A are router B, router C, router E, and router F. So it will share this routing table. It will share this routing table with B, C, E, and F. So similarly, B also, the router B also, it will share the routing table with A and C. Since A and C are the neighbors of the router B. Okay, so router B will share its routing table with both A and C. So similarly, E will share the routing table with A. F also will share the routing table with A. Even C will share the routing table with E. So while the router C, so here we can see, uh, so here we are not in the initial routing table. We don't have the value for we don't have the cost value for the router D as well as the router G. So when this will be get updated, so when it will updated in the sense when the so here so when the in C's routing table, it will have the information, cost information to reach the node D. Okay. So when the router C shares its routing table with A, so A will update this information. A will update this information. Similarly, in order to in order to determine this value for the cost of reaching the node G, so here in this case, when the router F shares its routing table with A, So in the routing table F, the cost to reach the node G will be available. So using this value, using this data, now the A's routing table will get updated. Okay, when the router F shares the routing table with A. So this is what will happen in the second phase. So first phase, each router will have the routing table, and in the second phase, all the routers will share its routing table information with its neighboring routers. With the time, the all the infinity value will be updated with the correct value. So next we are going to determine the final routing table. Okay, so next we are going to determine the final routing table at node A. So next we are going to determine the final routing table at node A. So we have to construct the same table again. So let me insert the table. Okay, so same table we are going to construct. Or else I can try to reuse this same table. It's not pasting actually. Yes. So now we have to so update this value for D. So how to update this value? So in the um, so in the graph, if you see, so we can reach the node D with cost 2. So there are many ways to reach the node D. For example, from A, we can reach from A to B, hop count is 1. From B to C, hop count is 2. From C to D, the hop count is 3. So 1, 2, and 3. But if I come via C, A to C, 1 hop count, and C to D, 1 hop count. So total 1 plus 1, 2. So always I have to follow the uh, shortest distance. Okay. So here I can replace the value as 2. The next stop router is via C. The next stop router is via C. Similarly for node G also we are having many paths. Uh, we can come to A to B1, B to C2, C to D3, D to G4. So 4 hop count. But if you come via F, A to F1 and F to G1. So 1 plus 1, we are having only total the cost as 2. So we can replace with the 2, and next stop router is F. Okay, so this is how the final routing table we have to form. So once this final routing table has been created, so this routing table also will be shared. So since we know that the third key aspect is every router shares its knowledge about the whole network only with the neighbors at regular intervals. So what it will do at regular intervals, it will share its routing table. So when, as we all know, as I told earlier, so B shares its routing table with A. C also will share its routing table with A. E also will share with routing table with A. F also will share with routing table with A. Then A will update this information. Update this information. And so this is the final routing table. So this final routing table also, it will be sharing it with all its neighbors. So what we can do is, so it is very difficult for us to, if there are more number of nodes in the network, then it is very difficult for us to construct the routing table for each router like this. So we have to construct for all the routers. We have to construct the initial routing table and final routing table. Instead, we can directly go for the global table. We can we can, so initial distances stored at each node or each router. So this table we can construct. So how to construct this table? So we have to write all the nodes from node A to node G, and this side also. Horizontally also we have to construct this table. We have to write all the node A to node G. So information stored at node. So how to fill this table? So initially we are going to take only the. So let me delete this part. So we have to um, find the global distances. Okay, we have to find the distances between all the routers. So here what we can do is, so initially we can substitute 0 for here. So the value is 0. Let me, so this is 0, and the value for reaching B to router B is also 0. C to C is 0, D to D is 0, E to E will be 0, and F to F is 0. So the diagonal value will become 0. Okay, and how to fill the remaining value from A to B. A to B there is a direct link, so the value is 1. A to C there is a direct link, value is 1. A to D there is no values are there. There is no direct link is there, so we need to insert infinity over there. Okay, so D to A to D is infinity. So since we are so this is the initial distances. We are calculating only the initial distances. So uh, A A to D is infinity. A to E is 1. A to F is also 1. A to G is infinity. Okay. So for router B we have to construct. So for B, B to A is 1. B to C is 1. B to C is 1. So remaining all it is infinity. Why? Because there is no direct link. So similarly, C to A is 1, C to B is 1, C to D is 1. So remaining there is no direct link, so I will substitute infinity. So for the router D, D to A there is no direct link, so infinity. D to B there is no direct link, so infinity. D to C there is a direct link, so 1. And D to E there is no direct link, so infinity. D to F no direct link, infinity. D to G there is a direct link, so 1. So for the router E, E to A is 1. So router A doesn't have direct link to any other router. So remaining all the values are infinity. So F router. So F has the direct link between A. So F to A is 1 and F to G is 1. So remaining all it is infinity. So this is how you need to fill this table. And the next one is uh, G, router G. G has a direct link between only D, router D and router F. So it is 1, 1. Remaining all is simply we can substitute infinity. So this is the final table. This is the initial table. So this is the initial table which is stored in the uh, routing table in all the routers. So this is this information. So this is the AS routing table. You can see it is vertically also you can see from cost of reaching A to A 0, A to B is 1, A to C is 1, A to D is infinity, A to E is 1, A to F is 1, and A to G is infinity. So this is B's routing table. Similarly, C, D, E, F, and G. So what we have to do? So next we have to construct the final routing table. So after this, we have to construct the final routing table. So how to construct the final routing table? So we have to update the values. So now we are going to construct the final routing table. So where and all we are having infinity. So these infinities has to be replaced by the values now. We have to, so where we have substituted the, um, we are having the infinity. So this value has to be filled up. So um, in A's routing table, while filling the A's routing table, final routing table, so now we are going to calculate the final distances global view. For all the routers, we are going to calculate the final distances. So A to D, from this graph, we can come via T if you come, the cost is 2. And A to G, if you come via F, the cost is 2. So for router B, A to D, sorry, B to D, B to D, the cost is 2. So if you come via A, 1, 2, 3, and 4, the cost is more. So always we have to consider the shortest path. So via C, if you come, we can reach D via C within the 2 hop count. So we have to substitute 2 here. And so B to E, B to E is via A we can reach to E. So the hop count is 2 again. So B to A is 1, A to E is 1. So 1 plus 1, 2. So A to F, A to F, sorry, B to F, B to A is 1 and A to F is 1. So 1 plus 1, the hop count is 2 here. And for G, you can go in 2 different paths. That is via B also you can traverse, or via A also you can traverse. Anyway, if you come, the cost will be 3. So B to C is 1, C to D 2, and D to G is a third hop, so 3. So the value is 3 here. So similarly, for this router C, we have to construct router C, C2. So C to A, B, C, D are already available from the initial table. You can reuse all these values. Only thing is we have to determine the value for the infinity. Okay. So initially it was infinity. So now we are going to calculate the value the same way, hop count method. So C to E. So C to E via A if I go, I can reach within the path cost of 2. Okay, C to E is 2 and C to F is also 2 via A. C to F is also 2. C to G is also, C to G is also 2 via D. So here 2. So next router D. So D to A. D to A is 2. Why? Because A to D is 2. Here you can see the table. A to D is 2. So here you can substitute 2 here. Okay. Similarly, um, so next A to B. So A to B. What is the value for B to A? Mm, Sorry, D. Next one is D to B. D to B. Here you can find in the table from B to D. What is the value is 2. So here also you can substitute 2. Or else you can calculate manually also. Okay. So D to B. So D to B is 2 via C. So value is 2. So D to E is 1, 2, and 3. D to E is 3 and D to F is D to F 1, 2 via G. It is 2. Next one, next router E. So E to B. E to B is 2. E to B will be 2. E to C will be also 2 via A. And E to D. E to D is 3. Output is 3. and E to F hop count is 2, E to F is 2, and E to G is 3. E to G is 3. So next one is router F. F to B is 2. F to C will be 2. F to D will be 3. F to D will be, why? Because you take this previous example, D to F. D to F, sorry, it is 2. D to F to D will be 2. Okay, via G. F to F to D will be 2 via D, via G. Next one is F to E. F to E is 2. So now this is completed. Finally, last router is G. So G to A. G to A is 2 via F. G to A is 2 via F. G to B is, anyway, if you go, it will be 3. Why? Because you have to consider B to G. What is the value of B to G? B to G is 3. Similarly, G to B is also 3. Okay. Next one is G to C. What is the value of G to C? C to G. First we have to, G to C is 2. Similarly, sorry, C to G is 2. So G to C is also 2. We can replace. Next one is G to E. E to G is 3. So here also G to E to G is 3. So similarly, G to E will also be equal to 3. So now this is the final table. So with this, the uh, tracing of the distance sector routing is completed. Okay, and you have to remember. So first, what are all the things we have learned? So what is the we have to write the yeah. So while answering in the examination also, you have to be very specific, and also first you need to write the definition of routing and what are the types of routing is available. Okay, so what are the types of routing is available? RIP protocol is there and OSPF protocol is there, and the three key aspects of the routing information protocol. So this you have to write, and you have to consider an example graph for this network. You have to initially construct the initial routing table for a specific router A, initial routing table, and final routing table for router A, and also at the end we have to consider the initial distances stored at each node. Global view we have to construct, so initial distances and final distances. So with this, the tracing will is over. Thank you all for watching this video.